The 48th question says 1 plus 3 plus 5 all the way till p plus 1 plus 3 plus 5 all the way till q is equal to 1 plus 3 plus 5 all the way till r. So let's find out what these sums are supposed to be. So first of all, you will have a plus l, which is 1 plus p into n by 2, but what is n in this case? So you got p minus 1 upon 2 plus 1, that has to be p plus 1 upon 2. So p plus 1 upon 2, but then that thing divided by 2 once again, so that's p plus 1 upon 4. Plus similarly you have 1 plus r into r plus 1 upon 4. That is, wait, got q over there. So 1 plus q into q plus 1 upon 4, that has to be equal to 1 plus r into 1 plus r upon 4. Fine, so this cancels. So you got 1 plus p squared plus q plus 1 squared is equals to r plus 1 squared, where p, q and r are some odd natural numbers, so these have to be even in that case. So these have to be even, right? So what can be the possible values of p plus q plus r in that case, right? That's what we are supposed to find, but how do we do that? So p plus 1 squared, we have to, okay, fine. So I will just set p plus 1 to be equal to 2 times a, q plus 1 to be equal to 2 times b, and r plus 1 to be equal to 2 times c. So that will give me a squared plus b squared is equals to c squared. Okay, fine. So that is just a Pythagorean triplet. So which of these options could be a possible sum of p plus q plus r? So you could have a, b, c being 3, 4 and 5. In that case, the sum that will be 3 plus 4, 7 plus 5, which is 12, but 2 times of that, so that's supposed to be 24, but that's not in the options clearly. Okay, so what else could happen is that a, b and c could be 2 times of that thing, so it can be 6, 8 and 10. Then the sum would be 2 times what we got previously, so that will be 48. But once again, that's not in the options. Or ABC could be something else, something like 5, 12 and 13. So 12 plus 13 is 25, plus 5, that's supposed to be 20. 2 times of that is 40, so still not working. Wait a second, sorry for that. So unfortunately I didn't subtract this 1 from the sum everywhere, so I have to subtract 3 from whatever we got previously. So the first sum that we got was 24, so if we subtract 3 from that, it could be possible that p plus q plus r is 21. But wait, p has to be strictly greater than 6, so maybe p can be 8 in that case. Sorry, not 8, p plus 1 would be 8, so p would be 7 or something. Yeah, so this works. So 21 can in fact work. So I will set ABC to be equal to 4, 3 and 5. Then that will give me that 2a is 8, so p has to be 7. So this satisfies the condition that p is greater than 6, and it is also a Pythagorean triplet, and 2a plus 2b plus 2c minus 3, that is 21. So cool, let's move on. So the 49th question says if a1, a2 all the way till an are in harmonic progression, then a1 upon a2 plus a3 plus all the way till an, so it's the sum of all these terms except a1. So I can write it as a1 upon, in fact let's just write for a general term, so ai upon a1 plus a2 plus a3 all the way till an, which is the sum of these numbers, minus 2 times of, no wait, not 2 times, so just 1 times, minus ai. Okay, so what now? I think that it will give me something like a harmonic progression, because if I flip it over, if I take the reciprocal, that will give me a1 plus a2 plus a3 all the way till an upon ai minus 1. Okay, so this is a constant and it doesn't hinder in the difference, and a1 plus a2 plus a3 all the way to an, it's like something which we multiply with every term, so that doesn't hinder in the okay, so that just multiplies the difference by this number, nothing else. Okay, fine. So these are supposed to be in harmonic progression. So the next question is, if log base 2 of 5 into 2 power, what is this thing, into 2 power x plus 1, okay, log base 4 of 2 power 1 minus x plus 1 and 1 are in arithmetic progression, then x equals, fine. So that will give me 2 times log base 4 of 2 power 1 minus x plus 1, that has to be equal to log base 2, I don't, okay, fine. So just 5 into 2 power x, I think, and then plus 1 separately. Yeah, that's how it's supposed to be. Plus log base, no, nothing log base anything, so it's just plus 1, fine. So what now? I can write this thing as half log base 2 of this complete thing. So this will be half log base 2, but then half gets cancelled with this 2, so that's a nice thing, fine. So that gives me log base 2 of, let us see, 2 power 1 minus x plus 1 upon 5 into 2 power x plus 1, that has to be equal to 1. So this has to be equal to 2 in that case. So that gives me 2 power 1 minus x, which is just 2 upon 2 power x, right? So 2 plus 2 power x completely divided by 2 power x upon 5 into 2 power x plus 1, that has to be equal to, so now that 2 power x goes to the right hand side and it becomes 2 into 2 power x. Okay, this is a solvable equation, so it's almost like a quadratic. So I will set 2 power x to be equal to u, so that will give me 2 plus u upon 5u plus 1 is equals to 2u. So that gives me 2 plus u is equals to 10u squared plus 2u. So that gives me 10u squared minus u. This is supposed to be 5u over there. Yeah, we are going correct on this, I think. Right, so minus u, and then you have minus 2 over there, that has to be equal to 0. But okay, so 20 can be written as 5 into 4, and yes, this is actually factorizable. So 10u squared minus 5u plus 4u minus 2 has to be equal to 0. So that pretty much gives me 2u minus 1 into 5u plus 2 is equals to 0. So u can be half or it can be minus 2 by 5, but it cannot in fact be minus 2 by 5 because we just set it to be 2 power x, and 2 power x has to be positive, so that's out of the option. So just get u equals to half, which is 2 power negative 1, and also equal to 2 power x, so x has to be equal to negative 1 in that case. Okay, that's nice. Then x equals to negative 1. Wait, what is this? Log base 2 5 into 2. Wait, that doesn't make sense. And 1 r in a AP. Yeah, we did everything correctly, so why this answer? It could be possible that we missed some solution, so let's just see. Okay, cool. So 2 times log base 4 of 2 power minus x plus 1. The inside quantity is positive, so no problem with that thing. You can use the change of base rule to say it's equal to log base 2 of 2 power 1 minus x plus 1 upon log base 2 of 4, which is just 2. So that will be like log base 2 of 2 power 1 minus x plus 1. That is equal to log base 2 of 5 into 2 power x plus 1 plus 1. Okay. And what now? This quantity is positive, this quantity is positive, so I can indeed do this thing. Log base 2 of 2 power minus x plus 1 upon 5 into 2 power x plus 1 has to be equal to 1. So that clearly means that this thing has to be equal to 2. What else could happen? No, nothing else can happen in this case. So in fact, none of these solutions are correct. You could take something like a natural log over there. No, that wouldn't be nice. So yeah, that's it. None of these should be the correct answer. I don't know if I'm missing a solution, but I think that's it. That should be correct. So let's move on. Okay, so the 51st question says the 15th term of the series 2.5 plus 1 and 7 by 13 plus 1 and 1 by 9 plus 20 by 23 so on is. First of all, let's make it simplified. So 2.5 is 4 plus 1 5 upon 2, and this thing is 20 upon 13. Then this thing is 10 upon 9. I think I already see the sequence. So this is actually 20 upon 4 into 2 is 8. This is actually 20 upon 18. Yes, the sequence is very clear. The denominators are going up by 5. So it is like a harmonic progression. Plus 20 upon 23 and so on. Okay, so you want to find the 15th term of this series. So that would be 20 upon, the first term is 8, I mean in the denominators, plus the 15th term, so 14 times the difference is actually 5 over here. So 20 upon, what's this thing, 14 times 5 is 70, so 70 plus 8 is 78. So that has to be, let's simplify this, 10 upon 35, 3 is 38, which is 5 upon, wait, no, 39 I think, 35 and 4, so 39. Yeah, that's correct. So 10 upon 39 should be the 15th term. Let's move on. So the next question is, if A, B, C are in a GP and XY respectively, wait, what? Be arithmetic means between AP and BC. Okay, fine. Then the value of A upon X plus C upon Y is. So first of all, let's just write some equations. You have that B squared is equals to AC. Okay, you also know that X and Y are the arithmetic means between AB and BC. So 2x is equals to A plus B, and similarly, in fact, that could be nice. I think that maybe we should substitute the value of x over there. Yes, that might do it. Okay, fine. So I will write it like this. So x equals to A plus B upon 2, and then y is equals to B plus C upon 2. That's much better. So now what? Now we'll just input these values into this equation and just hope for the best. So A upon, what's x? A plus B upon 2 plus C upon B plus C upon 2. So that gives me 2A upon A plus B plus 2C upon B plus C, and now it's just simplification, right? So let's see what that turns out to be. So that has to be equal to 2AB plus 2AC plus 2AC plus 2BC upon their product, which has to be AB plus let us see, you got A into B, then A into C plus B squared plus BC. Now I can input B squared as AC in that case. So this will be AC once again. Fine, and let's see what we get. So is there something which is like a common factor? Not seeing anything like that. Wait, actually this might work. Just might work. So 2 into, you got AB plus 2AC plus BC, and then over here also you have AB plus 2AC plus BC. So yes, this completely cancels, you just get 2. So this has to be 2. Okay, cool. Let's move on. The sum of the first two n terms of the AP 2, 5, 8 so on is equal to the sum of the first n terms of the AP 57, 59 and 61 so on, then n equals. Okay, fine. So the sum of the first two n terms of the sequence, that has to be let us see 2n upon 2 into, okay, so what's the difference? The difference is 3. So 2a minus t, that has to be 1 in this case, plus n times the difference, which is 2n times the difference, which is 3 in this case. So 6 times n, that has to be equal to, let us see, n by 2 of the sum to the first n terms of this series. So the first term is 57, so 2 times of that has to be 114 minus 2, so 112, plus 2 times of n, right? Okay, so that seems nice. So let's cancel these n by 2's away. That will give me 2 plus 12n is equals to 112 plus 2n. So 10n is equals to 110, so n has to be equal to 11. Looks correct. Okay, so the value of n in this case is 11. So let's move on. Right. So the next question is, if x, y and z are the pth, qth and rth term respectively of an AP and also of a GP. Also of a GP. Okay, fine. These are the pth, qth and rth term of a GP as well. Okay, so what do we know about this in that case? We know that y minus x, that has to be p times the difference. Fine. Sorry, not p times the difference. That has to be, I think, q minus p times the difference. Then z minus x. I think, yes, z minus x is over there. So, okay, in fact, let's just find y minus z first. Okay, so let's start like this. X minus y, that has to be p minus q into the difference. Then y minus z, that has to be q minus r times the difference. And then finally, what else do we need? X minus y, y minus z, z minus x. So z minus x, that has to be r minus p times the difference. Okay, fine. And what else do we know? We know that so in fact, I'm just using this to input into this expression so that we can maybe simplify that. Right. So what now? Also we know that because these are the p, q and r term of a GP as well, that means that y upon x, that has to be the ratio raised to the p power, wait, what happened? Sorry, the ratio raised to the p minus q power. No, the q minus p power, sorry for that. So it is equal to the ratio to the power of q minus p. Okay, then z upon y has to be the ratio r minus q. And what else do we want? We might also want x upon z. X upon z, that is equal to the ratio raised to the p minus r power. So that's the important piece of information which we wanted. Okay, cool. Okay, so now let's come to this expression. So you have x to the y minus z. Okay, so x to the y minus z is nothing but x to the p minus q times the difference. In fact, this is okay, we are running short on space. So x to p minus q times the difference, then y, and then it is z minus x on the power. So q minus r times the difference into z, and what is this thing? X minus y, which has to be p minus q. Wait, sorry for that, this is somewhat messed up. So it's x raised to y minus z, which is q minus r raised to the difference, yes, into y raised to z minus x, which is y to the power of r minus p into this difference, and z raised to p minus q into this difference. Okay, cool. Which is equal to, first of all, let's just take that difference common, right? And then what do we have? First of all, let's look at everything which has p as the exponent. So for p, you have y raised to negative 1. What is this thing? So y raised to negative 1, if I just put PD over there, fine. So y raised to negative 1, and what else? Z raised to 1. Okay, cool. What about RD? So for RD, we have x raised to the negative 1 and y raised to the first power. Then for the remaining part, which is QD, what do we have? We have z raised to the negative 1 into x raised to first power. Okay, fine. But we already know what this is supposed to be. This is supposed to be r raised to the p minus r power. So this thing turns out to be, let us see, and this is supposed to be r raised to q minus p power. So r, in fact, let's just call this r power d raised to some power. Let us see what that is supposed to be. So we got p into q minus p. So pq minus p squared. Is that correct? Doesn't look correct to me. So you got y raised to the negative 1 power, and then z. Oh, sorry, it's supposed to be y by z in that case. So it's like, okay, fine. Z by y, sorry. So z by y is corresponding to r minus q, and that times p has to be pr minus pq. Then this times, no, okay, yes. So plus, what else do we have? We have y upon x, which is corresponding to q minus p. That times r, that has to be qr minus pr. And you can see the symmetry that this time you will get the remaining terms, which is you got x upon z, right, which is corresponding to p minus r. So that times q is pq minus pr, no, minus qr, right. So minus qr over there, fine. So you can see that everything cancels over there. This cancels with that, this cancels with that, and this cancels with that. So this just turns out to be r power d raised to the 0th power, which is 1. So yes. Okay, what is happening?